Lessons 3 through 6, interpreting and using function notation and features of functions. So here's our function notation. This is what you will typically see, or you might see f of x, or they might use different letters. So you might see g of x, or g of t, or g of all sorts of things. So the name of the function is this first letter. So this example here would be function f. The thing in the parentheses is the input. So in this case, the input is t. Here, the input is referred to as x. And then the output would be the whole thing, f of t. So we're going to do some practice with that. So functions have function rules. And for this particular one, to get the output of the function, add 2 to the input, then multiply the results by 3. So pause and see if you can figure that out on your own. So let's see. Add 2 to the input. So our input here is x, right? Because it's f of x, so it's going to be x plus 2. Then multiply the results by 3. We're going to put a parenthesis around it because it's telling us order of operations. We first have to find the result of x plus 2 and then multiply by 3. So now we're going to take it over here to our table to figure out some different outputs. To figure out outputs with different inputs. So here, we have a table of inputs. We're going to find the output here. This is like we've done before in our linear equations unit, where we might have an XY chart like this, and we would have different inputs. And we would have a rule like y equals x minus 5 or something, and then we would figure out the outputs. So same thing, we're just using this function notation instead. Okay, so let's try it. X equals -2, so we're going to plug in -2 into our function rule, which in this case is x plus 2 times 3. Oops, x plus 2 times 3. So we're going to have -2 plus 2 times 3, so that is 0 times 3, which is 0. And so that, as an ordered pair, would be -2, 0. Right, we always write the input here, or the x, and the output here, which we often have been calling y, but we could also call f of x. All right, let's try another one. So here we have -1 plus 2 times 3. So -1 plus 2 is 1 times 3 is 3. So our ordered pair is such. Now we can go over here and we can graph these points. So we have -2 up 0, -1 up 1, 2, 3. And we could keep going. You will figure these two out on your own here. When you graph them, actually let's do the 0 together. So we have 0 plus 2. Times 3. So that will be 2 times 3 is 6. So 0, 6. So over 0, up 6. So now we can graph our line. This is a linear function, right? Because it makes a line. Not all functions are linear. This one is. Now, a little blast from the past, we're asked to identify the slope and the y-intercept. There's a few ways you can identify it. You can identify it from the graph. We can do rise over run. So in this case, we have to rise 3 for every time we run 1. Rise 3, run 1. So slope is 3 over 1, or we would just write it as 3. We can see here the y-intercept is 6. We can also tell it from the equation. Let's go back here to the equation. Now, I'm actually going to distribute the 3, so it will look a little bit more like our slope-intercept form of an equation. So that's going to be 3x plus 6. Now we could rewrite that. Instead of f of x, we could write it as y. And that should look familiar to us. That is, I'm going to write it up here, slope-intercept form, y equals mx plus b. And the slope is the number multiplied to the x, so that's our 3. The slope is 3 here. The y-intercept is the integer added to the x term. There it is, right there. Okay, let's do another one. Here we have a new rule, so pause the video and write the rule in equation form. So here it says multiply the input by 1/2 and subtract the result from 3. Now, we need to think about what are we going to write first? When we subtract something from 3, like if I said subtract 1 from 3, you would not write 1 minus 3. That would be wrong. That would be subtracting 3 from 1. Subtracting 1 from 3, we actually have to write the 3 first and then the 1. So our rule is actually going to be 3 minus, and then we're going to have to multiply the input by 1/2. 3 minus 1/2 x. Okay, so now we're going to plug and find some input-output pairs. Okay, when x is -1, we're going to have 3 minus 1/2 times -1. So order of operations, we first have to multiply the 1/2 times the -1. So that is 3 minus -1/2. And remember, when we subtract a negative, that is actually adding. So that means 3 plus 1/2. I'm running out of space here. That's 3.5 or 3.5. So our ordered pair would be -1, 3.5. Okay, let's maybe do one more. When x is 0, 3 minus 1/2 times 0, which is just 3 minus 0, which is 3. Okay, let's graph a few points. -1, up 3.5. Over 0, up 3. And if you kept, this is also a linear function. If you graph the other points, you would get this kind of action here. So what is the slope and y-intercept of this? So pause and see if you can figure that out on your own. The slope, again, you can find by looking at the graph. You have to, let's go from, say, this point to this point. You have to rise. You could rise +1 here and run -2. So the slope is -1/2. And then the y-intercept is this point, it's 3. From our equation, we can also see this. We have the slope is the term multiplied to the x, and then the y-intercept is just the integer. We could rewrite this as y equals, and then rearrange this, -1/2 x plus 3. That would look a little more like slope-intercept form for us. Okay. Now we're going to look at this graph. This is a graph which gives the height of a drone in meters per second after it leaves the ground. So drones have the ability to, here's a little, gosh, what does a drone look like? It has some propellers, right? And some feet. It kind of looks like a mosquito. Drones can go straight up and then come straight back down. And that's what happened with this drone here. Here's time. We can do the feet in meters. We can write our meters here. So let's first do this part. What is the drone doing between 0 and 2 seconds? So 1 second has gone by and it is 2 meters high. 2 seconds have gone by and it is 4 meters high. So maybe this is 2 meters here in our little drawing, 4 meters. So it's rising or going up. Between 2 and 5 seconds, what's happening to its height? Well, the height is not changing between 2 and 5 seconds. It's staying at 4 meters, so it's hovering. I could just say hovering. And then between 5 seconds and 7 seconds, it's taking 2 more seconds to descend. So I could say it's descending or going down. So we're going to do this table here. We don't have a function. And in fact, we're going to learn a new term here. We call this type of function that has different parts of it, right? So we could make an equation for this part of it. That's a linear function. But then this part is a different linear function. That's actually the line y equals 4, right? Because y, or f of x, is staying at 4 meters the whole time. And then this is a third linear equation. So we call this a piecewise function because it comes in 2 or more pieces, in this case 3 different pieces. So we don't have a function rule to figure out. There's no single rule. It kind of depends in what interval we're talking about. So we're just going to use the graph to fill this in. So when x equals 1, so at 1 second, what is f of x? What is the output? Well, it is, height in meters is f of x. We can just write that in for ourselves. It is 2. When x is 2, the f of x, the output, or height in this case, is 4 meters. And we could write these as ordered pairs. And they would match up to these points on our graph here that we've just done. You will fill out these 2 on your own. Now you're going to answer these questions. We can compare the outputs. Which is greater, f of 0 or f of 4? Well, here's f of 0. F of 0 is also 0. At 0 seconds, it's on the ground. And f of 4, in this particular function, is 4. It's 4 feet above the ground, so f of 4 is greater. So pause the video and do these other ones on your own. One of these I think is actually equal. The 2 things are equal. Now let's look at this one, f of t or f of t plus 1. So it's asking, t is time. So if you have t plus 1, that's 1 second later. So would we say that the drone is always higher? 1 second later, is it continuing to go up and up and up and up? Well, that's true for this piece of the function. 1 second later, it's always higher. But then after 2 seconds, it stays the same. And then for this piece of the function, it's actually lower every second that goes by. So we would say for this one, I'm just going to say it depends on the interval. So where in the function we're talking about, since this is a piecewise function. I'm going to stop the video and make another video for page 2.